Hey everybody, how's it going? I gotta take a picture. This is the first time I've given a talk in front of a crowd that had a balcony, so that's pretty cool. Sweet. So yeah, my name's Adam. I am a software developer at a company called Titan Co, where I work with Matt Stauffer, who delivered the keynote this morning. It's a pretty fun place to work. We get to do lots of cool stuff, work with Laravel all the time. I'm also the host of Full Stack Radio, like Sean had mentioned. Does anyone here listen to Full Stack Radio? Yeah. Woohoo, cool. I got lots of Full Stack Radio stickers if anyone wants any after the talk. I'm also the self-proclaimed world's strongest developer. That's a 275 kilo deadlift. Kilos for you guys. It was pounds the last time I gave the talk. So this talk is called Chasing Perfect. So what does that even mean, right? I feel like as developers, a lot of the time, we're always looking for like new ideas and things that we can learn and apply to what we're doing to make our code better designed or more maintainable. And especially people, like all of you here who come to conferences like this to learn more about what you do, it's definitely something that we care about, right? So, sometimes we latch onto these ideas though. So like 2013 was the year of the repository. And if we take all of our eloquent models and put them behind an eloquent repository that implements a repository interface, then we'll be able to decouple all of our business logic from our data access layer, and that's going to solve all these design problems and all these maintainability issues that we were having, right? And then in 2014, it was the command bus. Everyone got excited about the command bus in the Laravel community, and if we take all of our use cases and turn them into these, thin little handlers and commands that we can just kind of map all of the different things our system would do into this one strategy that we can apply to everything, and then we'll always know where everything goes, and everything's going to be so organized and so maintainable. But what I find happens a lot of the time is that we latch on to some of these ideas, and instead of looking at them as like interesting ideas and things we can learn and add to the tool belt so that when we notice opportunities to use them, we actually have the knowledge to apply them to those opportunities. I know, myself included, sometimes I see some idea and I get so excited about it, and I'm just thinking to myself, this is it. This is what was missing this entire time. If I had only known about this 2 months ago before we started that last project, it would have solved all the problems that we ran into, right? And we would have never had any of these issues, and we could have just followed this strategy and applied this pattern and just coasted for the rest of the project, and the code would have basically written itself. And that's kind of how I've run into some of these things sometimes, and I think we all know when we really think about that, that's totally not true, right? So for me, 2015 has been the year of Kent Beck for myself personally. So I've been reading a lot of stuff that Kent has put out over the last 20 years and learning a lot from it. But if you get into some of the material that Kent has put out there, you'll notice that most of the time he's writing about stuff like this. This is an example from Smalltalk Best Practice Patterns, one of the first books that he put out, where he says things like, the topics covered in this book are the daily tactics of programming. How do you choose names for objects, variables, and methods? How do you break logic into methods? How do you communicate most clearly through your code? This is the stuff that he's always focused on, some of this really low-level stuff, the day-to-day, line-by-line sort of code that you're writing. So what I thought was interesting is I'd never really seen Kent write about higher level design ideas or architecture or any of that stuff. And I had the opportunity to interview Kent for Full Stack Radio a couple months ago, and I was really wondering what he thought about that. So I specifically asked him, how come it is that you're always writing about this low-level design stuff, how do you name an object, or where should this method go on this object or this object? How come I never see you talking about hexagonal architecture or domain-driven design or any of these kind of grander ideas? And Kent paused for a minute, and then he said to me, I think it's because I don't really see the difference. Whether you have two elements in a statement or two services in some distributed architecture, the principles are the same, the problem solving is the same, the line of thinking, it's all the same sort of thing. And this really resonated deeply with me because what Kent was kind of saying is that design is fractal almost, right? And the same sort of effort that you're putting into all this low-level code, it's the same sort of thing that you're going to apply to this higher-level stuff. And it made me think, I kind of want to try an experiment. So what if I stop worrying about architecture and higher-level design and stuff for a little while, put that aside for a minute, and instead focus on the stuff that I see on my screen every single day, all day long, and how I can make that better, and how I can think hard about making sure things are in the right place and things are named what they're supposed to be, and stuff like that. And my hope was that by doing this, eventually, if I get everything right, well, not right, but if I do the best job I can at the low level, then my application will hopefully end up being the sum of its parts and will represent a well-designed, maintained system at the end of the day because I focus so much on all this low-level stuff. So I thought the absolute best way to kind of talk about this stuff with you guys would be to go through some real code and some real examples and see what we can do to make stuff better. And because syntax highlighting in Keynote is such a pain in the ass, I figured, I would heed the immortal words of Bill O'Reilly, and we'll do it live. Fuck it. So, any example needs context, right? So this is the app that we're going to be talking about. It's called Larapub. It's kind of like LeanPub, but we only sell Laravel books. And they're all existing books, but kind of just rebranded for the Laravel audience so we can make a little extra money off some existing people's ideas. So we got books like Patterns of Enterprise Application Architecture in Laravel, of course. Object Thinking, the Laravel version though. Design Patterns in Laravel. Domain-driven design, but in Laravel. Clean code in Laravel. And my personal favorite, 50 Shades of Laravel. I authored this one myself. So you can see, so far I've made $1,800 selling this week. Sold 60 copies, 370 copies sold total. That's 75% of the people in this room. It's a little messed up, but that's fine. So let's dive into some code. So in this system, imagine that when someone's trying to buy a book, they put it in their cart, and at some point they want to be able to maybe apply a coupon, right, so they can get a discount on their order. And this is a feature that we need to implement in this system. So I've got a couple tests here. The first one is saying that, an order that has no discount applied is not discounted. So we create this collection of books. Each book has its own price. These are all in cents, right? So $20, $30, $40. We stuff those into an order, and then when we ask the order for its total, we make sure we get the non-discounted total back from the order. Makes sense. Then we've got another test for a simple coupon where we're testing that a discount is applied when a coupon is added to the order. So again, we have a collection of books. Each book has a price in cents. We instantiate a coupon that has a code that someone might enter into the UI, and the coupon has a value of $10 in this case. So this is a $10 off coupon for their order. So we instantiate the order, we apply the coupon to the order, and then we just make sure that the total order value now is discounted by the amount that the coupon is worth. So we got a super simple implementation for this, right? We have an order class, take some books in the constructor, apply coupon, just sets the coupon as stayed on the order, and then total just checks to see, is there a coupon set? Well, then the discount is going to be the value of the coupon. If there's no coupon, then the discount's going to be 0. And then we sum up the price of all the books and subtract the discount, right? Pretty straightforward. If we run the tests, we see all the tests pass. Great. So imagine a new requirement came down the chain where now, instead of just having to support coupons that had a fixed value, like $10 off, $20 off, $15 off, you needed to be able to support coupons that had a percentage value, like a 20% off coupon or a 30% off coupon. So how could we go about implementing that around the code that we have right now, right? So the first thing that we're going to do, right, is check out a test for this. So this is kind of what I'm thinking, at least as our first stab at it. So we've got this test. Test an order is discounted by a percentage when a percent off coupon is applied. So we have an order that's made up of a collection of books. We instantiate a coupon, but this coupon's value is percentage-based, right? So we're going to add this is% property to the coupon so we know that it's a percentage-based value and not a fixed value. We're going to new up an order, pass the books in, apply the coupon, and make sure that the value that we get back is 70% of the total there. So we have $20 plus $30 plus $40, and that's going to be times 70%, so $63 or 6,300 cents, right, which is what we have here. So of course, if we run this, it's going to fail because we haven't done anything yet. So we're getting back this value now, which is just taking 30 cents off the order instead of 30%. So how could we go about implementing this, right? Well, right now, instead of where we're calculating this discount, we're just taking the discount to be the value of the coupon. So this isn't going to work for these two different situations, right? So what we could do, right, is we could check, well, if the coupon is a percent coupon, we'll do one thing, and if it's not a percent coupon, we'll do another thing. And that other thing is what we have here, right, where it's just a fixed value coupon. But if it's a percentage-based coupon, well, what are we going to have to do? Well, the discount is going to be the total price of the books, right, which we kind of have here, this kind of gross total, like before any discounts are applied. And we're going to kind of multiply that by the value of the coupon, right, and divide it by 100 because we're not passing it in as like a fractional amount or anything. So if we run this test and we make sure that we set this coupon to not be a percent coupon, since we're checking that now, we've got to make sure that this one's not a percentage-based coupon. If we run these tests, hopefully they'll pass. Okay, so the tests are green. So we've implemented the ability for someone to have a percentage off coupon in the system. But I think we can all agree, if we look at this code, it's kind of hairy, right? I don't think anyone would really be happy with this implementation. Or if you are, then you have a lot of opportunity to improve it. So the first thing that stands out to me is this nested conditional. I don't like conditionals, period, and I hate nested conditionals a lot more than I hate regular conditionals. So there's some interesting things that I think we can do here. So the one thing that I think is interesting, right, is we're calculating this discount here, but what are the dependencies for calculating the discount? So in this first case, the discount depends on whether the coupon is a percentage-based coupon or not, so information that the coupon holds. It depends on the value of the coupon, right, which is more information that the coupon holds. And it depends on the gross total of the order, which is information that the order holds. So anytime I see something like this where 2 out of the 3 dependencies for this calculation exist on a different object, it makes me think, well, maybe there's an opportunity here for me to experiment and see what it would be like if I moved this behavior to the other object instead of the one it's on right now, and see how that feels and see if I like it better at the end of the day. So let's try that and see how that works out. So what are we going to need to do, right? Well, first of all, we're going to need to implement this discount method on the coupon that calculates the discount. Maybe something that would help this get started is if we extract all this stuff into a discount method, so at least we're not really worried about how the total is being calculated and stuff when we're doing this extraction. So if we create a discount method here and we just move this code down there and kind of re-indent that so it doesn't look so stupid, and then return the discount again, and then we can just make that call up here. So we'll say the discount now is just going to be a result of calling this discount method. If we run these tests, hopefully they'll still pass. Yeah, and now it's pretty clear that we could just inline this discount call, right? There's not really any value in having this temporary variable kicking around. So if we inline that call, delete this, run the tests again, still green. That's good. So now I think we're in a better position to maybe extract this and move this behavior somewhere else, now that it's been pulled out into its own method. So we want to extract this stuff, right? The stuff that's calculating the discount based on all this information about the coupon. So let's pull up the coupon, and I think what we want to do is we want to add a discount method, and we'll figure out what it's going to take, but let's just get the implementation moved over and make sure our tests stay green while we do this. So it's going to be this same logic, but we're going to have to do a little bit of switching around here. So we're not talking about this coupon anymore. That's just going to be this. And this, where we're calculating the price of the order, well, we should just pass that in because we can't calculate it within here, right? So if we just pass that price in and then return this discount, and we run the tests. We haven't changed anything in the order yet, right? I just want to run these tests and make sure there's no weird syntax errors or anything so that I can catch any mistakes that I made way earlier. I think it's a really helpful way to work, especially if you have fast tests that you can run all the time. Definitely take advantage of it anytime you make any change. So the tests are still green, so we're in a good position to actually call that code that we implemented on the coupon now. So now the discount is just going to be equal to calling the discount method on the coupon and passing in this price, which we have here. So let's just move that up there. Just delete all this stuff, and hopefully when we run these tests, they'll still be green. Still green, great. So let's kind of get the lay of the land here and see how things look. Well, if we just look at the public API of this order class, what someone might want to scan if they're working with it as another developer on your team that just kind of wants to see what's going on, it's fairly simple. It's just like a simple constructor and 2 single-line methods. So the public stuff is pretty well put together. But this discount method, I think, is still like a little bit hairy. We can still do some work here. So let's look here. All we're really doing, right, is calculating this discount and storing it in a variable and then returning that variable at the end of the day. So the first thing that I would want to do here is just return these discounts right away instead of storing in a temporary variable. If I can get rid of temporary variables, usually that's a good thing. So if we run this, it should still pass. Cool. And I think it's pretty clear here that we don't need this else statement anymore either, right? Because we're going to return early anyways. So we can get rid of that else statement and just return 0 if we don't enter that conditional. Run the test again, still green, cool. In this case, though, this conditional kind of feels a little bit backwards to me. When I'm looking at this discount method, I'm thinking it's going to have to do some sort of work to calculate this discount. I don't like the complex part of the method living like to the right and nested inside of something. I would rather treat it more like a guard clause and just return 0 if there is no coupon. So invert this conditional, and then just move this out of there. So you can kind of see, well, this is kind of a special case. We have no coupon, so just return 0. Otherwise, here's kind of the meat of everything, how everything actually needs to work. So if we run these tests again, still green. That's awesome. So this method, or this class, is starting to look a little bit better. We've got 3 methods. 2 of them are a single line. One of them is 4 lines and has 1 conditional in it, but it's definitely better than where we were. One thing that I think we still have an opportunity to do here is remove a little bit of duplication, right? So you can see here we're calculating the gross total of the order in 2 places. So why don't we pull out like a private method for that too? So we'll call it gross total, since that's kind of what we've been referring to it as. We'll just move this code into here, return that, and now we can inline these calls to gross total. And now we've removed that duplication. So if for any reason the way that we calculate the gross total of the order before applying any discounts changes, at least it's all in one place now. So if we run these tests with any luck, we'll still be green. That's great. And now we can maybe look at this coupon class. So there's still some hairy stuff in here, and we can actually do that exact same refactoring that we just did in the last class, right? We can do early returns and clean up this conditional. So let's just do that quickly. So we can just return early, get rid of this return statement, make sure the tests still pass, still green. We can get rid of this else statement because it's not really accomplishing anything anymore. Run the tests again. Still green, great. So we talked about kind of how I flipped the conditional in the last one, so I thought it'd be interesting to talk about this case and why this may or may not be different. In this case, I'm not really too concerned about whether this case lives inside the conditional or whether this case lives inside of the conditional. To me, I don't feel like there's any clear happy path or anything. They're kind of equally likely. They're not. One is slightly more complex than the other, but I don't know that that necessarily means it should move anywhere. So you could have it one way or the other. I wouldn't really be too concerned about it, right? So this is looking a little bit better than we had before. But now a new requirement comes down the line. So now not only do we have to be able to support a fixed value coupon, right? We're $10 off, $20 off, whatever. We also need to be able to support coupons that are percentage off, like we're talking about. And now they want to add a coupon that when someone has X amount of books in their cart at least, then we give them a % off. So maybe like a minimum quantity, like if someone orders at least 3 books, then we'll give them 20% off sort of thing. So when we start thinking about how we're going to do this, it starts to get a little stressful to me, thinking about how this is going to work with this implementation that we have here so far. And Kent Beck has some really great advice that I'd like to share with you guys. When you run into situations like this where you need to implement something and it seems like it might be a pain, he had this tweet from 2012 where he said, "For each desired change, make the change easy, warning, this may be hard, and then make the easy change." So what he's saying is, anytime a new requirement comes down the line that you need to implement in your system, think carefully about it and try and figure out, what is it that I wish I only had to do? Like, if only I could just do this. Figure out what that thing is, and then make the changes you need to make to your system so that that is all you have to do to implement that new requirement. And this is kind of how emergent design and stuff works in general, right? You kind of build exactly what you need and nothing more, but then when the changes come down the line and you need to figure out how to support those changes, you can't be afraid to restructure things and rearrange existing code to support those features, because when you do things that way, you'll find that over time, your system is evolving in such a way that it's designed to accommodate the exact feature set and requirement set that has been coming down the line. And if the same types of requirements start coming, you'll start really reaping the reward of some of these design decisions that you're making, because you'll be able to see that you'll be able to pull in other stuff easily too, because you've been sort of letting your system adapt over time. So what does this mean for the code that we're looking at, right? Well, what's going to make this change hard or annoying? Well, we know that calculating the discount right now just depends on the gross total of the order. But this new coupon, this one that's based on a minimum quantity of books that someone has to order, that needs the quantity of books in the order too. So we can't just tell the coupon to give us a discount based on only the gross total, right? So what would we do? Well, what are we going to do? We're going to pass along the quantity as well. Is this parameter list just going to keep growing and growing and growing as we add different types of coupons? That doesn't seem like a very scalable solution, right? So what can we do differently? Well, what if instead of passing in the gross total, why don't we just let the coupon worry about what it needs from the order instead? So if we just pass in the entire order to the coupon, now instead of taking a price, it'll take an order, and here where we're getting this price, we'll call that gross total method. It's private right now, so we'll have to go back and fix that up. So if we go back to this gross total method and we make this public so we have access to it from within the coupon, if we run these tests again, with any luck, they'll still pass. So the tests still pass. And we've done one thing that I think is going to make it a little bit easier to add this change. Now, is there anything else that we can think of that would make it easier to add this change? Well, if we look at this coupon, right, what would we have to do? So we're going to say, well, if it's a percentage-based coupon, we're going to calculate the percent off. Otherwise, we're just going to return the value. So the only way that we're going to be able to implement this change, if we keep following this pattern that we've been taking, is adding another conditional. Instead of checking if it's a percentage-based coupon, we're going to have to check, is it a minimum quantity-based coupon? And then we're going to ask for different information from the order than the percentage-based coupon asks for, and different information than the fixed value type of coupon asks for. So when we really think about it, right, what are we doing here? We're basically doing a type check on the coupon. We're checking the coupon to see, are you this type of coupon? Or are you this type of coupon? Or are you this type of coupon? And when you start to notice things like that, what you really want to do here is you want to use a refactoring called replace conditional with polymorphism. So we can push some of this behavior to different objects. So why don't we try that out and see if that makes our code simpler, or see if that lets us, gives us code that we're happier with than what we have right here. So what does that actually look like? Well, I think what I would do first is we're going to update some of these tests, right? So this second test, the first one where we use a coupon, instead of passing in just a coupon, let's pass in a fixed value coupon. We'll run the tests so we kind of have some information about what we should be doing. There's no fixed value coupon. So let's just save a copy of this existing coupon, but we'll rename it to fixed value coupon. Rename the class, so we'll call it fixed value coupon. Go back to the test to make sure we import that class. Run the tests again, and this should pass because we haven't really changed anything, right? We've just created a new class that does exactly the same thing as the old class. But at least we have the separate classes now. So let's take a look at this implementation and see what we don't have to worry about anymore. Well, this is a fixed value coupon. So do we care to check whether it is a percent coupon? I don't think we do. It's clearly a fixed value coupon. There's no way it could ever be a percent off coupon anymore. So we can get rid of this conditional completely, right? Which means we also don't have to worry about telling this fixed value coupon whether it's a percentage-based coupon or not. We'll run these tests again. Still green. So that's pretty cool. So now we just have a class with a single method that's a single line. That does seem a little bit simpler than what we were doing before. So let's keep going then. How will we implement this for the other tests? So if we look at the next test, this is the percentage off coupon, right? So instead of creating a new plain old coupon, we'll instantiate maybe a percent off coupon. Run the tests and we'll get some sort of error, kind of tell us what we got to be doing here. So there's no percent off coupon class. So what do we got to do? We got to create a percent off coupon class. So if we save a copy of this, call it percent off coupon, rename the class to percent off coupon as well. Make sure we import that class. Run these tests and hopefully they'll pass. They do. So now we have an opportunity again to look at this percent off coupon and see, well, what is it that we don't have to worry about anymore? Well, it's the same thing. We don't care whether to check if it's a percent off coupon or not. It is a percent off coupon. That's why it exists. So we can get rid of the rest of that condition. Run the tests again. Should still pass. We don't care to tell it that it's a percent coupon anymore. That's in the name of the class now. Run these tests again. After we do that, make sure everything's good. And we're still good. So that's awesome. So how is this going to make it easier for us to make the easy change, right? Well, now we have separate classes for all these different types of coupons. So how would we go about implementing this change of bringing in a minimum quantity coupon? So I got some more tests here. Let's take a look at those. So the first test, it's got quite a long name. Test a minimum quantity coupon applies a discount if the order contains the minimum amount of items. So, again, collection of books with different prices. We'll pass them into this minimum quantity coupon, though, which has a value, which in this case is the % off, and a minimum quantity, in this case it's 2. So we're going to say, as long as the person ordered 2 or more books, then we'll give them a discount. So they ordered 3 books here, so they should get 20% off. So what should that be? It's 20 bucks, 30 bucks, 40 bucks. They ordered the minimum quantity, so that should be, what, 80% of that? So 72 bucks, yeah, so that's good. We also want to make sure that the minimum quantity coupon doesn't apply a discount if the order doesn't contain the minimum amount of items, right? So this one's basically the same deal, except we're just saying that the minimum quantity is 3 to get the discount. We're only passing in 2 books, and that the total that they get should just be the sum of the prices of those 2 books. So they shouldn't get a discount in this case. So let's see what's going on if we run these tests. Fatal error, class minimum quantity coupon not found, which is basically what I would expect, right? So how do we make this minimum quantity coupon? Well, we're saying that it's basically a % off coupon, but with a minimum quantity sort of condition attached to it. So we'll just make a copy of this % off coupon. We'll call it the minimum quantity coupon, and update the name of the class. And now how are we going to calculate the discount in this case? Well, it's basically this same thing, except we only want to do it in a certain scenario. And that scenario is basically, if the order quantity is less than the minimum quantity that we've established for this particular coupon, then we don't want to give them a discount, so we'll just return 0. Otherwise, we'll calculate the discount correctly. This is going to be a method that we'll have to implement. So if we run these tests, we're going to get some other useful information, hopefully. Minimum quantity coupon not found, so we'll have to import that class. Run the tests again. Call the undefined method app order quantity. So the order is going to need to be able to tell the coupon what its quantity is. So stick that up here where the gross total is. So we'll call this quantity, and it's just going to return the number of books that it's holding on to, right? Something like that. So if we run these tests, we're green. So that's pretty cool. So we've successfully implemented, this minimum quantity condition that we need to put in there. So is there anything that we can do to clean it up? Well, we talked about removing conditionals in some of the other places, so maybe we can talk about this one for a sec. So here we're just saying, if the order quantity is less than the minimum quantity that's required to get the discount on the order, don't give them a discount. There are clever ways that you could try and remove this conditional, probably, but I don't know that any of them would make the code simpler or clearer than it is right now. Like, the rule is a condition, right? So I think representing that rule in code as a condition, like you would say in real life, is probably a perfectly fine way to do it. Let's take a look at the order class. So the order class, it's got a few more methods than it did originally, but they're all just a single line, except for discount, which does have a conditional, one line of indented code, but otherwise everything's pretty simple. A fixed value coupon, single method, single line, that's pretty simple. A % off coupon, also a single method, single line, so that's pretty cool. So I wonder, is there anything that we could still simplify here? And, I don't mind conditionals like this that are real conditions checking like real rules, but this conditional, all we're doing is kind of trying to avoid having no coupon, right? We're trying to make sure that we don't have some sort of error where we're trying to access a method on null instead of an object, which is really like some sort of crappy computer detail thing that we have to worry about. It's not like a business rule that we're encoding into a condition. So is there any way that we could get rid of this condition, I wonder, right? It would be nice if we could just call discount and we didn't have to ask, do we have a coupon or do we not have a coupon? If we don't have a coupon, do this. If we do have a coupon, do that. So what I would like to be able to do is just always discount it based on some coupon. And we can implement this idea using what's called the null object pattern. So the null object pattern exists explicitly for helping you avoid these sort of situations where you're working with nulls all the time. So the idea is that instead of checking if something is null and then doing some different behavior, you essentially encode that behavior into something that represents the concept of nothing, for that specific context. So a lot of the time, maybe something will return an empty array instead of returning an array that has items in it. Or you might another way people use this is they might create like a guest in their system that's essentially a null user. So anytime like you ask for information about a user, you don't have to say, well, if this person is logged in, then show this. If they're not logged in, show this. You can just say, show this for the current user. And you might have a guest instead of a user that shows something different. So you can kind of push that logic into a different object and not have to check stuff up higher all the time. So how do we do that in this situation? Well, basically what we want to do is here in the constructor, we're going to want to make sure that we have some sort of coupon, right? We're not going to want to pass it in. PHP doesn't let you have like default parameters that are objects. They have to be scalar stuff. So the only way that we can have like a default coupon is to assign it in the constructor. So if we say every time we create a new order, it starts off with a null coupon instead of a regular coupon, then we can just call discount on this null coupon. We just have to figure out what this null coupon is going to do, right? And I think it's pretty simple. If we save a copy of this fixed value coupon, we'll just call this a null coupon. All this has to do is just never discount anything ever under any circumstances, right? That's basically what the no-op is. So if you have something that represents not having a coupon at all that means is that nothing ever gets a discount. So the rule is just discount returns 0 all the time. And this is a lot nicer than dealing with nulls, I think, in a lot of situations. So if we go back here and run these tests again, we have this test at the top, right? That's making sure that an order that has no coupon applied to it isn't discounted. So if we run these tests, if we've done this correctly, this test should still pass. No. What's the problem? 5 errors. Missing argument 1 for null coupon construct. That's fine. So we can just get rid of this trait that I was using to kind of keep things a little more compact on the screen. No worries. Run this again. All green. So that's pretty cool, right? So let's kind of take a lay of the land here and see what we've ended up with again. So we've got an order class. It's got a handful of methods. Now every single method in the order class is just a single line. There's not a single temporary variable in the whole class, which is nice compared to what we had before. We got the minimum quantity coupon is the only thing that really has any sort of significant complexity in it, and all that is one conditional that returns 0 if it's met. The percent off coupon is just a single method, single line, very straightforward, no temporary variables or anything weird that we have to worry about. The fixed value coupon is just as simple. All it does is return the value. So if you think about this compared to the code that we kind of were starting out with before, where we had nested conditionals, temporary variables, doing type checking in the wrong place, all this kind of crappy stuff. I think this is definitely an improvement. And this is not like trying to do anything fancy or trying to implement any crazy high-level stuff. This is just the result of like being careful and thinking hard about the stuff that you're looking at and working with and trying to figure out ways that you can make it clearer or simpler and remove conditions and stuff like that. And I think what we have here is a lot better than what we had before. So yeah. So what I'm really saying, right, is that when we're coding like this and thinking about this stuff, to me, I think it's all about the little things. We're talking about what Kent Beck was saying, where design is this kind of fractal thing, and it kind of scales up, and it's the same at every level. You're just kind of zooming the microscope in and out at a different level. Otherwise, it all looks the same. And I'm finding lately that there's a lot of opportunity for me. I've been programming for a long time, and I still find opportunities every day to take really fundamental ideas about object-oriented design, object-oriented fundamentals, and I find new ways to apply that stuff all the time and ways to make my code clearer without necessarily having to reach for really complicated, high-level ideas, right? Like, I think what happens a lot of the time in every hobby I've ever had in my life is you go through this period where you're not making progress and you are always reaching for something that's going to solve that problem for you. I started playing guitar when I was 7 years old, and I got to a point where I just wasn't happy with my guitar tone. I got to figure out a way to get my better guitar tone, right? And what did I do? I bought this effects pedal, and then I found out, oh no, if I buy this effects pedal and combine it with that one, it'll be better. Or my solid state amp is never going to sound as good as a tube amp. If I get a tube amp, it's going to sound so much better, and I end up with this really complicated rig and this rack system with all this crazy cabling and a MIDI controller. And I don't know, if anyone plays an instrument, hopefully you understand this crap, but it's complicated and stupid, and it takes up all your time, and you end up not playing guitar at all anymore because you're too busy tweaking knobs and doing all this bullshit. So for me, in the programming world, that's the equivalent of worrying about trying to implement all these ideas all the time, like these high-level ideas and patterns and stuff, instead of just figuring out, like, how can I make the code that I'm working with right now better than it was before? Like, the analogy in the guitar playing world, you know where my better tone came from? It came from, like, learning to hold the pick properly, or making sure other notes weren't ringing when I was trying to hold a chord, or making sure, that I was fretting things properly so they actually rang out properly, or that I was playing things on time, like the fundamentals. They'll take you very, very, very far. So what I hope people take away from this presentation, next time that you go and start a new Laravel application, instead of trying to implement anything crazy out of the box, just try like code inside the lines a little bit for a little while. Use the tools that come with the framework. Use Eloquent. Use facades when it makes sense, whatever. But just try and do a good job. Like, think really hard about every line of code that you write and think, is there any way that this line of code, this real line of code on the actual screen that I can actually see could be better? And if you do that all the time and just grind away at it, and every day you try and make your code base better than it was the day before, you'll find it pays off big time just by focusing on some of these like lower level fundamental ideas. You don't have to like switch out the ORM or any of this stuff. Like, I think a lot of time we blame our maintainability issues and our design issues on the wrong things, when a lot of the time it's just, we're trying to do something too complicated that we don't need to worry about. Like, use the fundamentals, get better at the fundamentals, figure out how to use fundamentals to improve your code, and I think you'll find that it scales up at the end of the day into systems that are better designed and easier to maintain. So, I'm Adam Wathan. That's my podcast. It's the sickest animation ever. I'm so happy with it. Full Stack Radio, check it out. If you want to listen to interviews with people like Kent Beck, we talk about lots of great stuff. I'm also working on a little project that I would love your guys' feedback on. It's a little CI tool for doing like PSR2 code violation detection with GitHub. So you open a pull request, and instantly you'll get comments on that pull request on the lines where there's style guide violations. So it kind of subs in for a human. It's not like totally available to everybody yet, but anybody here who wants to try it, just find me and I'll give you access. So I would love your feedback. And I got lots of stickers and stuff. What would DHH do? The ultimate question that you should ask yourself every day before you make any decision. Nitpick stickers and 2 types of Full Stack Radio stickers. So I got hundreds of those to give away, so find me if you'd like one. And yeah, that's it. So I'm Adam Wathan on Twitter. I blog at adamwathan.me. And there's the talk on going down.
Would anybody like to ask Adam a question?
Oh.
He's entirely open for questions. We have up here a hand. Anyone down here? I can give you the mic.
Just give me a second.
There's a guy over here.
Ow. Quick question.
Where am I looking?
Oh, right up the back.
Oh.
Are there any situations, apart from business rules, where you wouldn't use something like a null object to fulfill that capacity?
What do you mean exactly? Like any situations where I wouldn't use a null object? Like,
Yeah, so in that example, you used a null object class.
to get rid of the conditional, you mean? So are you talking about like this example we're looking at here where like this is a business rule with a conditional and like we can't use a null object here to get rid of this conditional, but
Yeah, that's my point. So in where you're not using business rules, are there any cases that you've seen where you wouldn't use a null object to clean up the code?
sometimes I wouldn't use one. Like probably in this case, like this example that I went through, I don't know that I would actually introduce a null coupon here. I just thought it was kind of a cool thing to introduce people to. I don't know that it actually, it is simpler in some ways, it's more complicated in other ways. It's just another tool for the tool belt that you can apply when it makes sense. And I think they are helpful in a lot of cases. There's a little bit of drawbacks, right? You have to maintain the same API across 2 objects and make sure that you're always thinking, well, what's the no-op condition for this new behavior that I added to this class that I now have a null version of? So there's some complexity there, but sometimes it's simpler than the other version, right? And that's kind of what you just have to weigh your decisions against all the time. Like, maybe that is complicated, but maybe if I didn't use it and tried to avoid using it, that would be more complicated. So things are inevitably going to get complicated. You just kind of have to figure out what's the least complicated option. And sometimes that least complicated option seems more complicated than what you started with originally, but as that, simple solution starts to grow and kind of get all spaghetti-like, what seemed like a more complicated solution originally actually ends up being much simpler than what it grows into. Any other questions?
Hi. So first off, very brave of you to do it live.
Thank you.
Congratulations on that. It went excellent. I have a question, not really big thing, but I noticed that you didn't refactor your tests. Is that something you normally would do or not really find important?
Well, what sort of refactoring were you thinking about? Like extracting out duplication and stuff like that in the tests? Or?
Yeah, basically.
There's kind of two mindsets about that. A lot of the time I prefer to just keep certain types of duplication in tests because I like to look at a test and be able to see everything that's happening in the test all kind of in one set of curly brackets, you know what I mean? Even if that means some duplication. Sometimes you'll have like some really complex thing that you need to build up, or you're writing an integration test that needs to like seed something in Elasticsearch or something crazy like that. I would definitely figure out ways to extract a lot of that stuff out. In this case, like I'm not really too concerned about the sort of duplication we have here, like where we're creating this collection of books. If you were to replace that with like get books or something, then you would lose information about what those books were or what was going in there. And a lot of people might use like a test double for this sort of thing. In the original version of this talk I gave, I just used like a dummy object for these books instead. I put the real thing in there just because I thought it was helpful for the example, for people to kind of not have to worry about mentally figuring out, oh, that's a mock of something. You can just kind of see it all there. And in this example, it's such a simple object to build anyways. I don't know that there's any benefit to trying to do anything different, but that's kind of a tangent not related to your original question, but hopefully I answered your original question too.
Yeah, so you created 3 coupon classes.
Sure.
But 2 of the names had to do with what kind of discount you get, if it's fixed price or percentage. But the other one had to do with when you get the discount. How would you handle, say, a minimum quantity percentage? Would you then just create percentage minimum quantity coupon?
Yeah, like this is a minimum quantity percentage-based coupon, right? If you had situations where maybe there was a coupon that was only applied, that was a fixed value coupon, say like $10 off, that happened when you had a minimum quantity, probably what I would end up doing is composing these objects. So I would have like a minimum quantity coupon that was like a decorator for regular types of coupons, and it would take a fixed value coupon in the constructor or a % off coupon in the constructor, and it would just contain that one business rule about it only applies it based on this rule, and then it would delegate what the value to apply would be to the underlying type of coupon. And you could combine all this stuff together and do all sorts of cool stuff. So.
Okay, cool. Thanks.
Could you explain why there was an error when you had the attribute access trait still?
Sure, yeah. So that attribute access trait is literally just this stupid little helper I made so that I didn't have to have a bunch of boilerplate in the classes showing how we were accessing some of these properties, because I didn't want the screen to be full of noise that was kind of getting in the way of the stuff that I really wanted us to be looking at. So it's a trait that has a constructor, which is bad. Don't do that in real life. That takes an array of attributes and literally just uses the magic methods to delegate to that array whenever you ask for a property. So it just cleaned up the stuff a little bit, so we didn't have to like look at one of these coupons and see a constructor that takes an order or any other dependencies and stores that in instance variables, when all we really care about is looking at like how this discount method works, sort of thing.
Hi, I'm just wondering what your own personal rules would be in case you're working with more messy legacy code as to when to stop, like cleaning and making it more perfect and more perfect. I know personally I could lose myself in hours doing this, and so does he stop, what your rule might be?
That depends on a lot of things, right? It depends on the budget that you have for implementing whatever this requirement is, how much work you think it might be to actually clean it up. I know in the past, anytime I've worked on legacy stuff, I've tried my best anytime I've had to implement something new to use that kind of Kent Beck rule and try and figure out a way, like, how can I make this easy? We had to implement a new feature. Well, what does it touch? How can I clean up the stuff that it touches? It might take you a little bit more time, but it's going to pay off ultimately at the end of the day, because the amount of time that you spend implementing new features on top of a not well architected or well put together code base is just going to grow exponentially anyways. And I mean, no matter what the project is, it's always going to get harder and harder to add features. I think any code base over time is going to kind of naturally head towards entropy, like no matter how hard you try. But you have to try. And if you don't try, then things are just going to turn into a big ball of mud way earlier than they should have to, you know? Does that answer your question?
Do we have any other questions?
I actually do. Do you think it would be clearer if you, instead of passing in the order in the discount method, to just pass in the gross total into the constructor?
Yeah, we were passing the gross total in originally, but then this coupon that depends on the number of items in the order, we wouldn't have been able to implement that without also passing the number of items in the order to every single coupon if we wanted to keep that interface for how a coupon calculates the discount the same. So I thought what ended up being simpler was to just pass the whole order and let each type of coupon be individually responsible for asking that order for the type of information it needed to calculate the discount in its specific situation.
Cool.
Okay, no more
Great.
questions.
All right, thanks guys.